Hello everyone. So in this section, we are going to finish the 1.2. So we are going to solve some easy differential equations. Let's take a look at this example. Example 6. So we have a differential equation, which is second differential equation, look like this. And we want to find the solution. So solution means it should be y equals fx. That is the solution. Okay, we want to find the solution, solve for y. Actually, we did a similar thing in case 3. Let's see, if we say this is acceleration, how to find the velocity, how to find the position function. So we just do integration, right? Do integral. So let's see, firstly, we integrate both sides of the equation, and the left side becomes dy dx, first derivative. So from this, it's kind of like this. Second derivative integral is just the first derivative, right? Okay, derivative and integral, they are the opposite procedure. Okay, so we do integration. Integral of 12x. So don't do derivative, do integral. So should be x squared here, and the coefficient should be 6x squared. And when we do the integral, usually we need to add an arbitrary constant, right? So here we add c1. You can just add c, doesn't matter. So next step, we do integration again. Okay, do integral again. So y equals, this one should be x cubed, okay, over 3. That's integral of x squared, and plus c1x, and add another constant c2. Simplify. So it should be 2x cubed plus c1x plus c2. Okay, so you can see this is the solution to the differential equation. And then in this equation, you can see c1 and c2, they are arbitrary constant. They can be anything, any constant, okay? And this is the second order equation. So second order usually has 2 arbitrary constant because we do twice integrations, so it always has 2 constant, okay? And for this kind of solution, we say this is the general solution. So what the general solution means? General solution always has arbitrary constant. Okay, so this is one example, and it's pretty easy. Let's do one more. Okay, let's do one more example. So let's see, find the general solution to this differential equation. Second derivative equals e to the negative x. Same thing, it's also second order differential equation, right? Okay, let's see. We do the same way. Firstly, we do one integral. Okay, the integral both sides. So e to the negative x. So e to the x dx, which is e to the x, right? And actually, what is e to the kx dx? Their integral, so it's e to the x over k. Derivative e to the x times k, but integral e to the x over k. Okay, remember, let's use this formula. And this is e to the negative x over negative 1. So let's put negative 1 in front. Okay, and general solution, that means we need a constant, a beta constant. So here we do c1. Next step, we perform another integration, and e to the negative x, and the negative x becomes positive x, right? And positive 1, c1x, and plus c2. So this is the general solution. General solution. Okay, let's see. You can try this. If I say second derivative equals this one, can you find the general solution? Let's do this problem. y prime equals integral sign should be negative cosine x plus c1, and y equals integral that one. Integral cosine should be sine. Okay, that's the general solution to this differential equation. Next, we are going to do initial value problem. So what is called initial value problem? Let me give you the definition. Okay. So for this one, we also call that just IVP. Initial value problem means the differential equation with initial condition. So for example, in Calc 3, actually we learned something like this. For example, if we have second order differential equation and we have y0 equals 2, y prime 0 equals 1. So this is the differential equation. Those are two initial conditions. Initial condition, do you know why? Usually, it's at when t is 0. If in physics, t is the variable, so that means t equals 0, that means initial, so that's why we call that initial condition. Okay. This is called initial value problem. Let me give the real definition, general definition. So we have a nth order differential equation together with n conditions. So if second order, we need 2 conditions. If we have third order, we need 3 conditions. With n conditions of the form where like yx0 equals y0 and y prime x0 equals y1 general. Okay, like this kind of thing. So you don't need to memorize this. You can just look at this example, the right side. So where y1, y0, and yn minus 1, they are all constant. It's like the right side. Okay, those are y's. And this is called initial value problem. Okay. That means differential equation with initial conditions. With initial conditions, okay, is called an initial value problem. Okay, that's the initial value problem. Next example, we are going to solve initial value problem. Let's see. Actually, the method is same as Calculus 3, what we did in Calculus 3. Solve the initial value problem. Okay, so here I give you we need a differential equation and we need the initial conditions. Okay, and the initial conditions are given by those two. So this is called the initial value problem, right? And now we're going to solve this. So let's see, same as last example, we find the general solution. Okay, we do one integral, negative e to the negative x plus c1. Is that right? Okay, and because the initial conditions are given, we can use the initial condition to find the c1. Let's see, in those two conditions, we are going to use the y prime. Okay, because y prime 0 equals 4, and here we have the y prime. So we plug in. So y prime 0, plug in, change x into 0, negative e to the 0 plus c1. Okay, right now we plug in 0 into x position, and the initial condition which is given by 4. Now let's solve for c1. So e to 0 should be negative 1 plus C1 equals 4. So what is C1? C1 equals 5. Right? C1 equals 5, that means let's plug into y prime. Negative e to the negative x plus 5. That's y prime. And next we do integral y equals e to the negative x plus 5x plus c2. And we get another arbitrary constant, but we have initial condition y0 equals 1. Same thing, plug in. So y0 equals what? E to the 0 plus 5 times 0 plus c2, and which is given by 1. Let's simplify. And this is just 0. And this number is 1 actually. It's 1 plus c2 equals 1. So c2 is 0 in this case. So our plug into our y. So y equals negative e to the negative x plus 5x, and c2 is 0. So that is the solution to the initial value problem. Okay, this is the final solution. Now let's try one exercise problem. So here I give you a third order differential equation, and we have 3 initial conditions. Let's find the solution, particular solution actually, satisfy this initial condition. Okay, satisfy those initial conditions. You can please try this by yourself.